All right, everybody. My favorite thing to talk about is we have this expression. 2 cubed is 8. Okay? And the reason we have radicals is so we can go backwards and say, what's the cube root of 8? 2. And one thing we want to catch at this point is where numbers are located, right? This is frontward and backward. Exponents are a shortcut, and radicals help us go the other way. Because if you have a forward direction on this equation, we need a way to go backwards. We all understand that. We all know that. We also know that the square root of 9 is the whole number 3. Why? Because, yeah. Well, everybody, you guys agree that this means this? All right. I've come all this way. What is the exponent on the 3? So, when I do this, we know the power rule. Remember our power rule. Our power rule says this. If I have x to the a power raised to the b power, that's equivalent to x to the ab. Right? You multiply the things. So, I have a 3 here. All right? This radical, okay, I want to think of it as I want to think of that radical instead of as a square root. I want to think of it as an exponent. What does it have to be to make this equation balance? Negative 1 times 2. Negative 2, that's not it. 1 times 2. 2. 1/2. Why 1/2? All right, hang on then. So that works. Hang on. So 3 to the half power squared, half times 2 is 1. 3 to the 1 equals 3 to the 1. Does this work for everything? Let's try another one. Let's try 2 cubed equals 8. Do we all agree with that one? All right, so here we go. Let's do that page. Do we all agree with this? All right. And again, does everybody agree that 8 can be written as 2 to the 3rd power? And what's the exponent on the right 2 over here? 1. Okay, I'll put that in red. We don't usually put it. All right, so now I want to change this radical. I have 2 cubed, and I want to change this into some power right here. So something times 3 has to give me 1. 1/3. Does that work? Absolutely. Hang on.
Wait. Is it the outside exponent over the inside?
Well, listen. I could have written this as 8, right? I was just trying to help simplify it. Right now it's still 8. What's 1/3 times 3? 1. 2 to the 1 equals... and then it comes back to what you said. Whoops. Whoops. Everybody, the 3 power here becomes the 1/3. What about the last one? Well, wait a second. There wasn't a number here, but what number do we always know is here? 2, because what times what? All right, let's go to another one that we know. How about, do we all know that 2 to the 4th equals 16? All right, so let's do the 4th root of 16. All right, how can we write 16? We can write 16 as 2 to the 4th. And again, the power on the right has to be, so, so hang on. All right, well, it's always going to, this power, this index is always going to be the denominator of a fraction because radicals and exponents are coupled. Come back to the very beginning. They're coupled by this idea. They had to work this way.
You don't have to break it that way.
Yeah, I agree.
But it's always
But it's more fun this way.
equals to 1 power.
So, all right, but hang on. We don't have to be pretty. If I take the 4th root of x squared, what times what times what times what makes x squared? Well, that's a lot of work, and I can maybe think of it. But instead of doing that, everybody, I can write x squared, and what does the 4th root become? 1/4. It becomes the exponent 1/4. Everybody, what's 2 times the 4th? 2/4, which reduces to, simplifies to 1/2. Hey, everybody. Yeah.
Okay. So what if your outside number is like 2 squared?
All right, we'll get there in a second. I'll show you. How about x to the half, though? Everybody. How about square root of x? X to the half. Now, everybody, let's go back to the very beginning. If I write square root of x times square root of x times square root of x times square root of x in here, is this x squared? Square root of x times square root of x is x. Square root of x times square root of x is ho, 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 ho. Yippee! So listen, there's a rule here. We've just worked our way around. The square root of x is equal to x to the half. The nth root of x is equal to x to the what power, you think? 1 over n. If n is 3, it's 1/3. If n is 7, it's 1/7. So you're just asking about powers. It doesn't matter what number. If you want to put multiple things up there, you can. We'll get there. That would make it a little hard. But I can do this. I can simplify this expression now because I can change. These radicals can't be combined. You guys agree with the way they stand?
Yeah.
Because it's the cube root and the 7th root. But x squared can be raised to what power? 1/3. X 7th over here can be raised to what power? 1/4. All right, now we have the power rule. What's a third times 2? 2/3. Multiply. X to the 7/4. Now, back to truck off. Before you jump off any bridges, everybody, what's a to the 4th? A squared. Why? Because you do what? So, who's got a calculator? Because I don't want to do this in my head. What's 2/3 plus 7/4? Ready to go, and I'll go faster. Here we go. 8, 21, 29 12. Make sure I'm right.
I got 1 and a 6.
No.
2 and 5 12. 29 12. Let me be clear. We never write mixed numbers as fractions, so you have to learn to convert. Because this is the answer. And we have now, listen, think about how powerful a statement we've just done. We've gone from these being something that we just have to leave to be able to get to one term up here with 2 different factors to 1 term, 1 factor. Woo! All right, if you want to check it, pick a number like 3 for x, and take the 3rd root of 9, the 4th root of 3 to the 7th, which is gigantic, and get some decimal and check it. Check 3 to the 29 12. And let's be clear in your calculator, guys. You can put a number in and check the value. This is how you enter this in your calculator. Everybody, it comes down to a cool rule. It had to work because of the 2 cubed is 8, cube root of 8 is 2. But here it is again. X to the square root of x is x to the half. Cube root of x is x to the what? 1/3. 4th root of x is, the nth root of x is x to the 1n. All right, and with that, we have now introduced fractional exponents.